Alright, in this video we'll be working with formulas. Now in practice, formulas almost always involve more than one unknown because the whole point of them is to describe relationships between multiple quantities. Which is why the equations we'll be seeing in this sort of video will look a little bit different, even if the ideas we use are very, very similar, which you'll see soon hopefully. So one case is where we're given a formula and we're given most of the numbers. So for example, this v equals u plus at is a physics thing, it's always true under certain situations, and we're given that v is 20, u is 5, and a is 2. Maybe we measured this, maybe this was the outcome of some experiment we did. We want to find the value of t given these three things. So here's our formula, and we're given three things, and we'll see them one at a time. One is that v is 20, and so the v in here can be replaced by 20. Then u is 5, so the u can become a 5. And we're given a is 2, so the a there can become a 2. And we're using these three bits of information to find the value of t, which is here in our formula, and so there's the t over there that we're trying to find. And so after putting those three bits of information in, that equation we come up with, the 20 equals 5 plus 2t, is something that should look quite familiar to us. Okay, so the way we solve this then is, well, I guess the first thing to do is we need to remove the 5, so we subtract the 5 from both sides. So we get 20 minus 5, which is 15 on the left-hand side. On the right-hand side, the 5 is now gone. And so if 15 equals 2t, we can work out how much t is if we divide both sides by 2 then. And so we do that, and so t must be 7.5. Okay. But more often than not in, say, science, in the real world, numbers are not so nice. They're not like the 20 and the 5 and the 2. They often involve a lot of decimals, or they're very big, or they're very small. And so actually, quite often, it's even easier to not put the numbers in first. It's often actually easier to work with the formula itself and to reshuffle those letters around before putting numbers in if we need to afterwards. Okay, so let's see an example of that. This one will be a little bit trickier. Okay, but the language we use is to make v, say, the subject of this formula. And again, what that means is I'm not going to use any numbers for e and for m and for p. All I'm aiming to do when it says to make v the subject is I find my v in the formula, and I want to try and reshuffle things in this formula until the v is by itself on one side of the equation. So you can see right now that e is by itself, e equals something. I want to reshuffle things until it looks like v equals something. Okay, so grab our formula and let's work with this. Now I want to get that red v by itself. I'm going to leave it red so that we can keep track of it, but I want to get that one by itself, and we'll try and remove everything else one at a time. So right now there's a plus p sticking at the end there, so I want to remove a plus p. I can take away a plus p if I subtract p from both sides. On the right side, the p will go away. On the left side, we're going to get a minus p because I'm subtracting it. Now, after I've done that, I've got mv squared over 2 on the right side. I can get rid of an over 2, a divide by 2, if I multiply both sides by 2. So on the right side, all that will do is kill the 2 on the bottom. On the left side, I'm going to multiply all of it by 2, which means I need to put that 2 in brackets when I multiply. Okay? Now we don't need to expand this, but you've got to be mindful of that when you're multiplying both sides by 2, you've got to make sure you bracket it to express that all of it's being multiplied by 2. Okay? Now I've got mv squared, so we're getting closer. I need to now get rid of that m there. So now it's v squared multiplied by m. How do I get rid of multiply by m? I need to divide by m. So on the right-hand side, the m will disappear. On the left-hand side, we're going to get all of that and divide it by m. So it'll be all over the m. Now I've got one more step, which is to undo the square. Now we've got to be careful when we do this because squaring's a bit of a tricky thing, right? 5 squared is 25, but negative 5 squared is also 25, right? Because when a negative gets multiplied by itself, it goes positive. So actually there's going to be 2 options for this v. It could either be positive or negative, and both of them work. So the opposite of squaring is square rooting, but we got to make sure we allow for the fact that v could be positive or negative, and either of them work, right? And so when we take a square root of both sides, we've got to make sure we take plural square roots of both sides, right? Which is why you'll see that plus or minus symbol appearing at the end there, because the answer could be positive or negative. Now, in practice, if this was a real formula that we were working with, which it actually is, we might know by the context, by maybe the physical situation, whether the answer's meant to be positive or negative. But as a purely mathematical thing, we don't know. So we've got to allow for both of those, okay? Because both positives and negatives square to the same thing. It goes positive in the end anyway. Okay, now this is probably the trickier part of this, so maybe look through that again slowly if you need to, but ask questions if you need to as well, and I'll see you later. Thanks for watching.